4:30. Okay. Study jam Friday from 4 to 6. You want to be here for the study jam because I will tell you right now with all the love in my heart, the way that I did really well in college and all of my math courses is I found people to work with that didn't understand the math as well as I did. And that was my study.
Everybody? Did he ask you questions that you're right about?
For the most part, yeah. But like we would form study groups and I would go like really like ready to just answer questions that people had and work with them and learn from them. And then I would walk away and I'm like, I'm done. I'm ready for like anything the professor's gonna throw at me. Like that was studying. So if you are able to stay Friday from 4 to 6 and work with the AB students, oh my God, that is like we've created the best study environment for the 11 of you.
Thank you.
So I hope you're going to be here. You're welcome. Other things that you need to know: you need to have your calculator fully charged. Fully charged. You need your calculator for the work that we're going to do today, so don't put it in there yet. Here's why you need it fully charged. Friday, we're going to put your calculator in press to test mode, which means your battery is going to drain a little bit, not wicked fast, a little bit faster because that blinking light takes up some more battery power. So, the other thing is the charger is going to go to Miss Gedeller this weekend, so Friday at 4 o'clock, you need to take your calculator out of the docking station and just take it home. Hopefully you've got a cord, you've got all the things. I will for sure have the charger Monday when we're in the cafeteria, but there's going to be 80 people in the cafeteria, and there's only 10 little spots in that docking station.
No,
BC
I mean,
BC
Yes, BC gets the priority because I'm telling you about it right now, which would mean as soon as class is over, put your calculator in there. Okay. All right. Tonight's homework is coming from the practice questions. Here are the numbers. Get them written down. 9, 11, 12 and 13, 15 through 19, 22, 23, and 26. Those are today's Powerball numbers. 9, 11, 12, and 13, 15 through 19, 22, 23. 26. Now, for those of you that can read this, there's a 52 that's circled. 52 is a free response question. I've circled it because any of you that choose to do this tonight, an early release day where I'm staying for tutorials, if you do the whole problem and you turn this into me tomorrow, your lowest homework assignment grade evaporates and gets replaced with a 100, even if it's a missing grade.
Why do you say that?
Aaron, Polymon, David, and Lewis, did you all hear this?
Yes.
Just checking that Aaron, Polymon, David, and Lewis have heard that there's an opportunity for your lowest grade to go away. I lay, yes, it means that like an 88 can disappear and become a 100, but for the other 4 fools, it means that a missing grade can go away and become a 100. Carmen, your lowest grade of a 97 might become a 100 this way. Alright, let's quickly check last night's homework, and I'm going to ask you to do something different with this. First we'll go through and just mark it right or wrong. Okay. You guys had to do 1 through 8, was that right?
1 through 8, 10, 14, 35, 37.
Okay, like that's all going to fit in my old man brain.
Yes.
Okay, number 1 is B. Number 2 is G. Number 3 is B. 4J. 5B. 6H, 7, that looks like I circled C. No, I couldn't see.
No,
I also was doing this in urgent care, so cut me some slack. 8 is J. And then you guys had to do number 10?
Yes.
H. And then it was
14.
14, J. 35 to 37, so now we flip to the back. Okay, 35, D for dynamite, 36, H, and 37, B. Okay, so right now we don't have time to go over these. Okay, but tomorrow and Friday we have lots of time to go over multiple choice tomorrow and Friday. What I am going to ask you to do is grab an index card or a post-it note from the container, and I'm going to ask you to do something different than what we've done before. Next to your name, I want you to write the numbers of all the questions that you got right. I'm creating a little tracking sheet that I'll give back to you tomorrow to help guide your studying. For the friends watching this at home, I'm going to email it to you guys directly so you can just print it out and you don't need to worry about getting it from your BC teachers. But on an index card, just write down your name and then all the questions that you got right. Don't tell me 10 out of 13, that doesn't do me any good. All right.
I'm tired. 4J, 5B. Oh, what I did.
Oh, so that's how
Oh yeah, what if we got a regular boy?
Oh yeah, can we put like a star by it?
Yeah.
like boy?
Yes.
Put the right one or the wrong?
Right one.
Lewis,
If you guess, put a star by it.
Steven,
Gold arrow.
Giselle, LA, Palamon.
No, he's making.
I'm wondering if one of these
Why not? Hurry
three
up.
belongs to you. Giselle, LA, Palamon.
We give it to you?
Just put it in the middle of the table. If you didn't just get the homework assignment back from me, it's because you didn't put your name on it. So I have two assignments that were turned into me yesterday. These look very male. So let's start it over here.
It looks very
No, no.
nice.
Myra's.
It's mine.
Oh, okay. If you can put your name on it, that would be good. Sorry. I didn't say you look male. You're.
I mean.
We did have David impersonate you the other day, so this could be like a lingering effect. All right.
They asked me to. They told me David scoot over his seat, so
Okay.
help my
All right. So you guys have tonight's homework. You turned in how you did on last night's homework. I'm creating a tracking sheet that'll help guide your studying. I'll have that for you tomorrow. I just couldn't get it done today. Here's what we're going to do for the next 23 minutes. The best way for me to work with you guys for the next 2.5 days is to just expose you to some of the hardest questions I've created or the College Board has created in the last couple of years. So the goal is to push your thinking as much as possible. Question 48, we used 2 years in a row on the trimester exam, and I will tell you it was a bloodbath. So this is question 48, it's on page 18 in the practice questions. What I'm going to ask each of you to do is take 2 minutes of just silent reading, thinking through this problem, planning your attack. Polymon, if you don't mind, I'm going to have you drive the laptop. At the 2-minute mark, we're going to have a quick conversation about the problem, and then some of you are going to decide to work with me. Some of you are going to physically move to a different table if you want to work on your own. But for the next 2 minutes, absolutely silent. Read through this question, mark it up, get your calculator ready, be ready to talk in 2 minutes.
Yes, except for, yeah.
I probably have to log in over there, Paloma. me backseat.
Okay, Paloma, she's all yours. Alright, Steve, are you all done? Alright, so let's have a quick conversation about what's going on in this problem. Andrew, give me a quick summary. What's happening in this problem?
We're trying to find for the first part, or
Just in general in this problem, what's the
Okay.
situation?
talking about the rate at which water enters the tank and the rate at which it leaves.
So we've got one of these, like Miss Blake likes to call this like an in and out question. We've got water going in, we've got water coming out. A very familiar situation. We've been here before, right? Sometimes it's been an amusement park, it's been a swimming pool, it's been a sand pile, but it's one of these multiple rate functions. Okay, things that might get missed or things that might be confusing. Something that you read and you're like, whoa, this is gonna make me stop and think. Aaron.
The two functions and things corresponding to the graph.
Okay, we've got two different functions. We've got f of t and g of t and like how they go with the graph. Other things, other really important things that we want to draw some attention to.
Oh, I think the piecewise function.
The piecewise function, this is sort of a new thing for us.
Yeah.
Other things? Anything else that might be a little bit confusing here?
Oh, there are 2 points where the functions intersect.
Okay, we've got two different places where the function intersects, and actually they are kind to give you these things. We're going to find out that they're not so kind in just a little bit. No one's actually mentioned that there's an initial condition in this problem. And maybe because we're not worried about that being confusing, you've got 5,000 gallons in the beginning.
Oh, yeah.
Okay? Alright, so if you haven't gotten this set up on your calculator yet, please do so. Palomone, if you can start graphing. And for those of you that just want to go solo on this problem, you feel really good, if you can actually physically move to that side of the room, either the back table or the side table, so I know not to draw too much attention to you. And for those of you that are moving, solutions are over here. Carmen, you're in control of the solutions. Okay. So we've got 100x squared sine of square root of x. Okay. You're going to want to play around with the window a little bit. Right, now they're being kind. They gave you the window, so let's use the window. Right, so window settings. We're going to go, what, 0 to 7. What about y min, y max? Looks like, what, 0 to 2,500? Okay. I think one of the things that really messed with some brains with friends is, how am I going to graph a piecewise function? And you said, why not?
No.
Why not?
No, I said you're not everything.
Oh, we're, okay. Do we have to worry about graphing the piecewise function?
No.
Why not?
What's given?
Okay, well, the graph is given to you. I mean, you can kind of like sketch it by hand if you wanted to. Something else that you might want to consider doing, rather than graphing the piecewise function, how about just graphing two different lines? Right, so let's graph a line at y equals, what is that, 250? And another one at y equals 2,000. Your calculator can graph a piecewise function, but I'm not too worried about that right now. It's G of t equals 250 and then G of t equals 2000. Alright, so we've got the graph set up. They gave us some intersection points. Life is good. A, how many gallons of water enter the tank during the time interval 0 to 7? Round your answer to the nearest gallon. What are you going to do this? Let's get some hands on this. How are you going to figure out how many gallons of water enter the tank during that interval 0 to 7? What would you do? I see one.
Well,
David, what are you going to do?
Yeah.
Palamon, you can start doing it. David, what are you going to do?
A,
Yeah, for part A.
definite integral,
Definite integral
of t
of f of t
with respect to t
with respect to t
from 0 to 7.
from 0 to 7. Congratulations, David. You just picked up the first point on the test. Now, my question is, why do we do a definite integral? What is it that you read in the problem that tells you, Myra, I have to use a definite integral here?
Because you're trying to find the number of gallons and, the amount of gallons, and the function is the rate.
Okay, f of t is telling you how fast water is going into the tank. The definite integral is always going to say, oh, you were asking how fast here. I can tell you how much by doing a definite integral. And if you do this on your calculator, Palamon's telling us that the answer is 8,263.806 gallons. And yeah, if you write this as your final answer, you don't get the second point. Giselle, why are you not going to get the second point here? You want to read this one really carefully. What is it that we're looking for?
Your answer to the nearest gallon.
Right, and so I've got an answer that's accurate to 3 decimal places, but I need nearest gallons, so the final answer, 8,264 gallons, that gets you to the second point. And I would say for the 11 of you, I would expect that on a question like this, we're going to get both points. This is not going to be the problem. Is that fair?
Yeah.
Okay. B, I want you to have some conversation with somebody near you. For the time interval 0 to 7, find the intervals during which the amount of water in the tank is decreasing. Give a reason for your answer.
Oh, between.
What's it gonna take for the amount of water in the tank to
Yes.
decrease? I'm gonna come over here and have a quick conversation with the two of you.
No.
What's it gonna take for the amount of water in the tank to decrease?
1.6.
One is gonna be 8,000.
5.
It's what?
You gotta evaluate those.
Yeah.
If we're thinking about water, we've got water coming in, we've got water coming out.
Wouldn't it be a good idea to
Because if
the
that's-
average is going in per each hour? And then if that average per hour is less than the total amount exiting per hour, that's how you're increasing?
You're kind of right and you're kind of wrong, because it doesn't have to be with an
Unless it's
average.
from 0 to 1.
If the amount of water in the tank is decreasing because something really specific is happening.
That's water going in, I mean,
Oh, wait,
that's
no,
water going in and
I think
Because
that,
this is where the.
But you want to be careful, because we're talking about rate functions, don't use the word less, they are rates. You want to talk about in rate language, like fast and slow.
Oh, it's
No, you need to
increasing
understand, the
faster
hard
than it's
part
increasing.
Is
Not quite.
understanding, at one point,
Can I say it?
617.
Okay, what are we thinking over
if
here about water
the
level
function,
decreasing?
if the rates are switching from more water entering than leaving or more water.
Is everybody okay with that?
And you're right.
So water, or another way you can say it, water is leaving the tank faster than it's
Water
going
is
in.
decreasing faster.
So friends over here, what have we decided? What has to happen for the water level to decrease?
You know, since that, I was trying to find out something like calculating.
Leading function has to be faster than
Than the entering function, right? Basically, water has to leave the tank faster than it goes in. Okay, so the conversation I've had with pretty much everybody is something to the effect of water level decreases means that f of t, the rate that water enters the tank, has to be less than g of t, the rate that water is leaving the tank. Don't say how much water, because these are rate functions. We have to talk in the language of rates, which is fast and slow. So you could just say f of t is less than g of t, or if you want to go with a verbal argument, you could say water is entering the tank slower than water is leaving the tank. 1 point for this. Now the next question is, what's the interval? Can you go back to the graph? And that's why I think something like this, it's sometimes going to be helpful to just like maybe do a little bit of color coding. So for me, the blue is leaving, and the black is going to be entering. The entering is L of t, the blue is g of t. Ile, where do you see f of t is less than g of t?
From 3 to the intersection of t plus 5.07.
So f of t is less than g of t. The black is less than the blue from 3 until this intersection point. Is everybody okay with that? Is that it?
No.
Where else?
From 0 to 1.6.
Okay, and so from 0 to, what was the intersection point?
1.617.
1.617. And then the other one, what is it? 3.
To 5.076.
5.076. Let's have a conversation about parentheses and brackets here. At 0, is f of t less than g of t? Okay, so brackets. At 1.617, is f of t less than g of t? So I'd prefer that you use parentheses here. The College Board would probably let you get away with a bracket in this case, but the best answer is going to be a parentheses. At 3, look at the graph.
It's going to be right.
Oh, it's gonna be a.
Because
At 3 parentheses because the graph isn't even defined.
oh,
Okay, and at 5.076,
Bracket.
not brackets.
It's not.
It's going to have to be parentheses. I think this is being wicked picky, but I want to make sure, especially with you guys, we're having that level of detailed conversation. So 1 point for the comparison, 1 point for the interval. We're up to 2 points. Every College Board question is worth a grand total of 9 points. There are 5 points built into this next problem. I want you to read this question and you're going to know why. You're going to know why when you read it.
Oh, I can go over here. So yeah, what time is the water?
why don't we do like I think
So you need to find.
Right now.
Here we go, reading that.
That's absolutely.
Okay.
So now they gotta get the change.
Alright. For 0 less than or equal to t less than or equal to 7, at what time t is the amount of water in the tank the greatest? Aaron, you read that word and you said right away,
Absolutely.
this is an absolute maximum kind of question. As soon as you realize you have been confronted with an absolute max or an absolute min kind of question, I need you to start thinking, what's this process? What do we do for an absolute max or an absolute min question? First thing you want to think about, your candidate. Where could the amount of water in the tank be greatest? So that's where do you say?
The intersections and the.
So the intersection points and the endpoints. Thank you for going with the absolute most popular wrong answer. The intersection points are not your candidates here. And here's why. At the intersection point, what's happening to the water level? At this intersection point. Uh-oh, can you, I don't know what you did there.
Nothing is happening.
At the intersection point, there's a change. What's happening to the water level before? What's the water level doing? The water level is decreasing or increasing? Decreasing. Decreasing from 0 until this intersection point because L of t is greater than this guy over here, or F of t is greater than G of t. I think I labeled him wrong over here. Afterwards, after the intersection point, from the intersection point until 3, the water level is increasing, and we continue to increase until we get to 3, and at 3 what happens to the water level? Decrease until we get to the next intersection point, and now we're increasing again. So where is your candidate for a maximum?
Probably at 3.
Probably at 3. I need something stronger than that.
Well, candidate is 3.
The candidate is 3 because what happens at 3, the water level makes a change from increasing to decreasing. That's why it's a candidate for a max. Celeste, does that make sense? Okay. But here's the thing. 80%, at least 80% of the students who even made it to this problem said it's intersection points because candidates are always intersection points. The College Board has come wise to teachers that are not doing a good job teaching, and they're like, we're going to push your thinking a little bit more. It's not intersection points, your candidate. So that first point comes from the candidate. So we said candidate at t equals 3 because water level changes from increasing to decreasing. First point earned. Is everybody okay? All right, now what? Lewis, what do you do from here? You've got your internal candidate. Any other candidates? Got to look at the endpoints. Okay, we've got endpoints at t equals 0 and t equals 7. Myra, we've got our internal candidate. We've got our endpoint candidates. What's your next move? Okay, we've only got a couple minutes left. The key thing here is we need to evaluate. You need to evaluate the thing you're trying to maximize. What we're trying to maximize is the amount of water. So what I need, and this is where like Mrs. Blakely, she's getting a lot of love today. Mrs. Blakely would say like, all right, here's the time, here's the water, here's the amount of water. Right, she sets the table. So at time 0 we need an answer. At time 3, at time 7. At time 0, how much water? 5,000. Okay, no point awarded for that. Time t equals 3. I need to figure out how much water. Not plug in f of
You
t.
find in.
Because what I want is the amount of water.
You find it
I need a definite integral of f of t dt.
from 0 to 3.
From 0 to 3. I like it, I don't love it. No, that's not the problem. Yeah, we're missing a lot right now.
Oh, plus.
How much water at time t equals 3?
Oh, 500 plus that.
5,000.
I mean 5,000
5,000 plus this amount minus
Oh, GMT.
minus the integral from 0 to 3 of g of t. And now another place to mess with your brain. Because what's g of t? From 0 to 3 is going to be 250 with respect to t. Okay, we've only got about 2 minutes, so if you guys are okay, we're not going to like finish off the computation there. It's just pop it into the calculator. I do want you to have a conversation about this next one. How are you going to figure out the amount of water in the tank at time 7?
Adding the answer for the previous thing also, because we did come to that water here.
So you can
0 to 7.
No.
0 to 7. Yeah.
I was.
It'd be 0 to 7. Left of t.
And that's one of those things where they're trying to get you past like, oh, I'm in like this automatic mode.
Huh?
And I'm like,
You know,
stop.
you know how from 0 to
Yeah, 0 to 7 G of t.
and then 3 to 7 GOT.
No.
Yeah.
What was that?
Shut up.
Both.
Can't you just do 22, 52, and then
Yeah.
0 to
Oh
7?
yeah, you can subtract 2 to 2.
Alright, just about everybody is looking good. 5,000 plus an integral from 0 to 7 f of t dt. Minus, now I need an integral from 0 to 7 g of t dt. Right? How much water I start with, how much water I add, how much water I take out.
You're gonna need to break that.
and I'm gonna have to break this apart because
It's
two different.
it's a piecewise function. I need two different parts here. And I have to do this carefully. This minus sign is going to be a pesky minus sign. What you might want to do is do like parentheses, 0 to 3, what is it, 250?
Yeah, plus
Plus the integral from 3 to 7,
2000.
2000 dt. And you're going to get a couple of numerical values out of the calculator. And I think if all goes well, it's at t equals 3 where it's greatest. Okay? So tonight's homework is a whole bunch of multiple choice. That's what's absolutely due tomorrow. The optional bonus assignment is question number 52. You do that one question, start to finish. Your lowest homework assignment grade evaporates and becomes 100. See you later.
I find it funny how he comes and he's as well.
What's this, a Jasmine? You're a jerk.
Say. What was that? He's like, you're sitting.